So when we are doing with the queue, yeah, there will be two main operations, Enqueue and DQ. Enqueue means insert. So we want to input one element, and the element will be at the end of the queue. DQ means we want to remove and returns the element at the front of the queue. Okay. So for example, this one, Enqueue. So I have the element 1. When I enqueue element 2, so it will be saved here. And then if I enqueue again, it will be saved at the end. Okay. If I enqueue again, it will be saved at the end. If I enqueue again, it will be saved at the end. So there will be 1, 2, 3, 4, 5, 6. Okay, until here 6. So if I DQ, means I will start from the number 1. So it's different with the stack. The stack will remove the top. So number 6 will be removed first, because we call it, this is in the stack, we call it last in, first out. But in the queue, we call it first in, first out. 1 enter first. So 1 will go out first. So we call this is queue. And there are 3 auxiliary operations. We call it first, length, and is empty. The first means I want to know what is the element at the first. And then length, I want to know how many elements in the queue and whether the queue is empty or not. There will be one exception, whether the queue is empty or not. So for example, I have queue, okay, queue, this indicate the queue, and I can use like list, I can use array for this, and then I will make the one function enqueue. This enqueue will insert an element 5, so the queue will have 5. And then I will enqueue, so I will insert a new element, and the element will be at the end. So now we have 5 and 3. If I check the length of the queue, it shows 2. Okay, so 5 and 3. And then if I DQ, it means I want to remove the first element. What is the first element? It is 5. So the element in the queue becomes only 1, which is 3. And then if I check is empty, no, because we still have 1 element. And if I DQ, then it will give the value 3. Okay, because the element remaining is 3. Yeah, so it will remove that element. Now it becomes empty. It will check is empty. Yes, it is true, because no element inside the queue. What about the queue? Error, because no element in the queue, so you cannot do any removal. And then you want to insert again, so there will be 1 element, and then you insert again, there will be 2 elements, 7 and 9. If you want to check what is the first element now, it will return back 7, because 7 is the first. And then if you want to enqueue, then you will put 4 at the last index. And then now if you check the queue, it becomes 3. And then if you DQ, yeah, it will remove the first element, which is 7. And so on. Okay. So the application for the queue, you know, is about a waiting list. So when you are in a waiting list, of course, the first will get the service and the last will get the last service, or it is in the bureaucracy. So if you go to the government office, yes, you will have this kind of queue. or if you are accessing the shared resource, like for example, printer. In one printer, you want to print multiple documents. So the first document printed will come first. In a multi-programming, there's also a queue. Okay. And in the indirect application, it can be an auxiliary data structure, and it can be a component for other data structure. So we will just go toward the array-based queue. When we want to use array, you know, the concept of array, we can extend or we can enlarge the queue. Okay. When we enlarge the queue, okay, or when we want to increase the size of the array, okay, there are two strategies. Okay, so hope you still remember the incremental strategy of array and then the double strategy to increase the size of the array. But in the array-based queue, we have one way to keep the size. Okay, so we do not need to increase. We do not need to enlarge the size. In order to still fit with the size of the array, we use the circular fashion. What is circular fashion? So let's suppose we have F and R. F is the front element and R is the immediately past the rear element. Array location R is kept empty. So whenever we have the element, this is the front. Okay. The front means this is the element in index 0. Okay. If you see from the example here, so the element, there's an element in index 0 if it is a list. Okay. But whenever you do this one, for example, you DQ, what happened? If you DQ 7, then 9, which is from the index 1, now it becomes index 0. 4, which is from index 2, now it becomes index 1. So there is a shift. There is a shift for this element. In order to fit with the size, so we can make the circular fashion. So it means whenever we have now we have the F here, and then the R is empty, and suppose this is the Q. So if we remove the element in index 0, then we update the F. Maybe the first F equals to 0. But when we remove it, so we remove and we change the F, now it becomes 1. And then if 1 is removed, we delete, then we change the F equals to 2. If we remove the index 2, okay, so we again delete this one and change the F into 3 and so on. So we update the variable F to know where is the current from. And also R, we can update R to find out where is the current rear. Rear means the end, and front means the element which is in the front. So let's suppose like this one. We can reuse the modulo operator. Okay, I guess you still remember the modulo. In order to use the circular fashion, when we want to find the size, how can we know the size of the Q. Now we have this circular fashion, and the pink color is the element that available in the Q. But the white color means we have no element. There will be no element. So how can we know the size? So maybe you can calculate just like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, from your eyes, it is easy to calculate 10. But how will you calculate if it is in the form of an array? How will you calculate if it is in the form of a list? So in this list, we have like, yeah, the total is 17. Okay. So this is 17, the n is 17. And then now I would like to put the variable f. The front is in the index 4 and the rear is in index 14. Okay. And how can we get the size? So the size will be 17. So n minus f plus r. Mod means modulo with the symbol percent n. So if I have 17 minus 4, 4 is the index of this front, and then 14 is the index of the rear. So the total will be 27, and then 27 mod 17. So the result will be 27 divided by 17. Yeah, 27 divided by 17. It is about the remainder. Okay. So 27 mod 17. You can check on your Python later. Okay. The result is 10. So we have the size is 10. What about the second? Now, whenever we have is empty, okay, so it means the variable f will be equal to the variable r. Okay. And let's suppose if it is a circular, okay, so once the f, if the rear already reached the last one, so it means if it is in the index 17 and there is no other place to put the new element, then it will go back to the index 0. So the rear now it becomes in the index 4. Okay. So if there is no place after the index 17, you will return back to the index 0 because the index 0 is empty. Okay, so the front part is empty. So we just put from the index 0, 1, 2, 3, and so on. Now, if we have like this, n equals to 17, the front is index 11, and the rear is in index 4. So what is the size of this Q? So we can calculate by seeing this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yeah, we can calculate easily with hand. But how the computer knows? So you need to use again this formula to the size. So n means the size of the Q, which is 17, and then we know that the front is 11 and the rear is 4. So after we have this one, yeah, the result is 10. 10 mod 17. Okay, so we can say this is the, again, we want to get the remainder with the percent. So 10, remainder 17. So the result is 10. Okay, so we can get the size is 10. So if you want to check when the operation enqueue throws an exception where if the array is full, so we need to find the new R. Okay. What is the new R? Okay. So here is the algorithm. We will make one algorithm enqueue, and then we want to put the object O. If the size now is n minus 1, the index, if we have the 17, so the index will be from 0 until 16. Okay. So if it's already 16, then yeah, we need to do the full queue exception. So we cannot do more than the size. If it is not n minus 1, then we can keep doing this one. So it means if all location has been filled with elements, then you cannot put more elements. But if there is still empty space, okay, if you have this empty space, then put into the index R. Okay. And what is R? The index R will be updated by R plus 1 mod n. Suppose now we have the R, okay, equals to 14. Okay. So R means here, yeah, is index 14, and then I want to insert one element. So the new R will be 14 plus 1, so it means 15, modulus 17. So the result will be 15. So the new R will be shifted to the index 15. And there will be a new element in this section. Yeah, if you have R equals to 4, then you will have R plus 1, which is 5, modulus 17. So this element will be filled with a new element and the new R will be shifted. Okay. So the same with the element in 16. Okay. If R is 16, then 16, if there is a new element, you will need to do it 16 plus 1, and then it becomes 17. So 17 mod 17 equals to 0. It means the R, the new R will be 0. And when you dequeue, okay, when you dequeue means you want to remove. Okay. Before you remove, you need to check whether we need to give the exception if the queue is empty or not. If it is empty, then you need to give the exemption. So you can see the result of errors. Okay. If it is not empty, then let O be the object of the queue in the index of F. And then F will be updated to the F plus 1 mod n. So the formula will be the same with the R. Okay. And then we will return O, or the object that we remove. So in the Python, I will show you the Python. There will be three kind of variables. The first is data, and the other is size, and the other is from. So we want to know whether the data is it is a reference to a list instance with a fixed capacity, and the size is the data to know that how many numbers in the list, or in the queue. And then front, yeah, we want to know what is the first element. So you can take a look on the Python. You can take a look on this Jupyter Lab. I put one more IPYNB about array Q. The same with the array stack. We want to make the Q concept into the Python with array concept. So the first will be the constructor. As I mentioned, there are three kinds of data. So the first is the data. Data means, yes, there will be a blank element. So there is none means blank, and then it is multiplied by the default capacity. So the default capacity is 10. So you can change, but now let's fix into 10. So it means we have 10 size, and all the elements are null at the first time. And then the size is 0 and the front is 0. So if you want to know the length, so it will return the size. It depends on the operation. If it increase 1, then the size will be added by 1. If it is empty, then we will check whether the size equals to 1 equals to 0 or not. And then you will check if it is the first. Then I would like to return the front. If I DQ, it means I would like to get the answer, and the answer is the data at the front. If it is empty, print Q is empty. If it is not empty, then you will check the front. After you check the front, so make the front equals to none. So it means you make it empty, and then you will update the front with front plus 1 modulo length of the data, and size will be reduced by 1. If you do Enqueue, so again you will check the size. Okay, so the size, if it is equal to the length, it means I need to enlarge the array. Okay, so the strategy can be incremental or it can be double. So in this case, I would like to double the array. And we need to put one place to insert the value. In this case, I would like to input the E, and then I would like to check the availability. So the availability will be the front plus the size, remainder the end. So what is front plus size? Front plus size, it will be equal to the rear number. And then I will put the element E into the index available, and then size will be added by 1. Okay. So the resize means, we want to increase the capacity. So if we know the original capacity is 10, and if 10 is not enough, we want to make it double. So make it 10 to 20. If 20 is not enough, we want to make it double. So we want to make it into 40 and so on. And this is the same that we learned before about the doubling strategy. So I will skip this one. So if you run this array Q, and I have the Q equals to array Q, and this operation the same with the one that I presented in the PowerPoint. So you will get this result. 2, 5, 4, 3, and so on. Q is empty because we have the exception. And then if you want to check the data, then The remaining data will be 9 and 4. The remaining data will be 9 and 4. And if you can see, the location of 9 and 4 is not in the index 0 and 1, but it is in the index 0, 1, 2, 3, and 4. Okay, because we always update the F and the R. Okay, I guess I need to stop here. So we will meet again on Monday. Okay, and the mid-exam material will be until what I explained on Monday. Okay, then any questions, comments?